Hello, my name is Emmett Hohensee. I'm hosting this part of the Hamfest TV, sponsored by Gigaparts. You're going to be walking through with me for the next 30 minutes or so, and with thrills, chills, and adventures of ham radio excitement. But before we start this segment off, what we're going to do is we're going to be announcing the prize winner of the Yaesu 817 radio. And that lucky person just happens to be... Can I hear a drum roll from everybody? There we go. Yeah, there we go. Okay, it's the FT817 QRP radio. Call sign is KK6HQT. Peter Parks from Petaluma, California. I hope I said it right. And if you're here, please prize. The radio itself is a nice QRP radio. This is a fantastic radio for just about getting... I've literally used a radio like this to talk around the world. 5 watts, you'd be surprised what you could do with it. And it's offered here through Gigaparts. And if you're not here, basically they'll be getting in contact with you. Okay, now. My name is Emmett Hohensee, and I'm the chief engineer for RadioWavz. And I'm here on the behalf of Gigaparts. I'd like to talk to you about some of our products, which are really kind of cool. And kind of fun to work with at the same time. It's nothing revolutionary, nothing new, nothing that just really just kind of changes the way we do business, but it's a cool antenna. Okay, we're going to be talking about the RadioWavz hex beam antenna. Some of you probably already have heard about it. It's initially, it is an antenna that was originally designed quite a while ago. That it basically is a 2-element Yagi. Okay, and what they've done is they've configured it into an M shape, okay, where you're able to literally compress the space, so it's only like 30% smaller than your normal dipole. If you were using a regular 20-meter dipole, it would take up about 33 feet, right? Now, if you had a Yagi, was a 2-element Yagi at 33 feet, what would you have? You'd have something that would be approximately 33.5 feet wide, and it would be 16 plus feet long. So that's a considerable amount of space. How much space do you think that would take up in your backyard? Quite a bit, wouldn't it? Well, the interesting thing about the 20-meter hex beam is it only takes up 20 feet of space. That's considerably smaller than what you would think of, as far as with just a simple dipole that you had sticking up in the air and rotating around. And then you add that reflective element, which is still smaller than what you would have on your normal Yagi, which is 16.5 feet? Well, it's only 10 feet. So you have a turning radius of only 10 feet. Now, the nice thing about the hex beam is you have several different configurations. Well, that's kind of freaky, isn't it? Okay, you have your Yagi. Okay, and then you have what's called a Moxon, which, who's all familiar with the Moxon? It's basically kind of a square kind of a looking thing. The whole idea behind the Moxon was an antenna that was space. Okay? So people said, okay, I can get just a little bit more out of there. So another guy came up with the idea of a reflected M. So what they did is they configured the antenna into an M shape and the reflector into an M shape, which reduced the space even more. And then finally you've got the reflected W, which is what we've finally called the hex beam. So literally the reason why we call it a hex beam is because it takes up 6 sides, and if you look at it from up above, it looks like a hexagonal diagram. Over here, you'll actually see, if you look right over the curtains, you can actually see a real live RadioWavz hex beam in real life. It doesn't take up a lot of space, but it does a lot. The thing that people are quite interested in is, what kind of a pattern would you kind of expect to get from a hex beam type antenna? Hey, it's smaller. It's 30% less space, but yet it's what? It's smaller, so you shouldn't get as much out of it, right? Well, guess what? You don't. You do. You get about anywhere between 6 to 7 dBi gain on the antenna, which is considerably better than a dipole. It's not as good as a full-sized Yagi, but yet you have the directivity and you have the ability, the small size and directivity and ability. And with the pattern, as you can see, you have a really good front lobe. Okay, we're losing it? Okay. Okay, we're switching out microphones because apparently, interesting thing. When you're in a ham radio convention and you're using wireless microphones, guess what happens? Everybody's got a radio on their hip. And what do you think they transmit on? Okay, never mind. I'm not going to get into that. That also reminds me of one other little thing, too. The people here at the Huntsville Hamfest this is one of the best Hamfests you could ever go to. I personally enjoy going to it. My wife enjoys going to it. But there's one little disturbing thing happened to me today when I was going into the lunchroom. And now understand, I'm a ham radio operator, so I'm a what? I'm a ham. And they were handing out ham sandwiches. So is there something wrong with this picture? No, anyway, a little bit of cannibalism going on there. Ham's eating ham, get it? Okay, there we go. Anyway, this is a diagram of what the hex beam itself looks like. The advantages of a hex beam antenna is that it takes up less space. It takes up, how do I say this? It takes up less real estate. And in some cases, many people don't expect to see this type of an antenna on your roof or in your backyard, and they're going to ask you, what is it? I got a friend of mine in Dallas, Texas, that put one of these up, and his wife decorated it as yard art. Literally, he has it up 25 feet in the air. He has his wife has all these different hanging vines off the midsection of the end of the tower itself, so it literally looks like an ornament in the middle of the garden. But it's really his ham radio antenna, which I think is kind of cool. The things you need to look at when you're looking at a hex beam is the design itself is oops, let's go back to the paper. Here we go. You got that? There we go. Okay, I understand that it's not always the prettiest in the world, but as you can see, it's a hexagonal shape. It has the way it's designed is this back section here that looks like a C. It almost looks like a Pac-Man, doesn't it? When you kind of look at it, it kind of looks like a Pac-Man from the side. Anyway, the side that looks like the open end of the Pac-Man, that's the radiating side. The back section is a C, so that is your reflector, which gives you the broad banded capabilities of the antenna. And then the front section, which looks like an M, or actually more like a W, that's the director or the radiator itself. Now, how do you get all of these antennas to work in one specific place? Since the 20-meter hex beam can be configured in, let's say, a 20-meter, a 6-meter, a 10-meter, whatever, how do you get them all to work together? Well, interesting thing is they do play well together. There is a little bit of interaction over time, but you have a central bus on the antenna itself that gives it the ability to have one simple feed point, to have it literally a directional antenna, not have to worry about traps, not have to worry about how to, what are we going to do in the wintertime when the wind blows and when the ice and snow builds up on it. How do I say it? There's a couple other things that you need to think about too. It's light. The antenna itself is light. It's 19 pounds. My wife, I've got a picture of it. I don't have time to pull it up, but I've got a picture of my wife doing the Statue of Liberty kind of thing with that full-sized hex beam out in the parking lot when we were putting it together. So that's kind of cool. You can always go to our website if you need to know more information about about the antenna, at www.radiowavz.com. I know we're bouncing around a lot. There's just so many things that we can talk about the hex beam. This is a good example of what your radiation pattern is of the hex beam from about 35 feet up on the 20-meter band. As you can see, it's quite nice. It goes in the direction you want to go. I've got some video set up on our website where we've got literally the antenna is pointed towards 14. Let's see, we're listening to the Maritime Mobile Net. Anyone listening to the Maritime Mobile Net on 14300? We're literally listening to the Maritime Mobile Net. We rotate the antenna. I think it was something like 25 degrees, 45 degrees. The next thing you know, you can't hear them at all. So it really nulls out the signal well. And I think at times that really is the thing that makes up for the antenna not being the full-size dipole, but a fraction of the size of a normal dipole, is the fact that it's able to cancel out a lot of noise. where our shop is located, we have a very noisy transformer. How many people have a transformer that's really noisy in their area, or you've just got a lot of noise that you just got to deal with on a regular basis? Well, the interesting thing about the hex beam, by rotating it out, quite often it cancels out that noise, because now you're pointing in the direction that you want to go. Or if you want to find out where the noise source is, you just point it to peak noise, and then there you go. You found your noise source. I'm trying to pull up a couple more things real quick. We've got some people in the audience, so I do have a couple things. If you guys have some questions, please feel free to raise up your hand and ask a question. I'll be more than happy to answer for you if you have a question. It will handle full power. So I have one friend in Oklahoma. He has a Henry amplifier. Need I say more? And he does CW, and he's made some mistakes in his life with the amplifier and on 20 meters and then on 10 meters. So the antenna works great at high power. Now imagine 1,500 watts, a small beam antenna. You're able to put the signal right where you want. It weighs 19 pounds. Each component is literally no more than 46 inches long. So you can put it in a carry-on case or like a duffel bag type case and carry it with you just about anywhere. It's excellent for the DX competitions. If you want to go someplace in a really wild and crazy place, that would be it. If you wanted to hook up an ICOM radio like a 7600, that would be a great thing to hook up. As a matter of fact, that's one of the things that I've been using when we've been in the field a lot is a 7600, which has really been a cool thing to have when we're using it. But anyway, anybody have any questions so far yet? Someone's got to have a question. I see faces with questions. Okay, I'll keep going. The other part of our Sentinel hex beam offering or product line offering is we also make a product that no one else makes in this market. It's the 40 meter hex beam. So it's literally the hex beam that is not the 20 meter, but it's a 40 meter through 10 meters. It's twice the size of the hex beam that you see here today. It's approximately, you have a turning radius of 22 feet, total diameter of 40 feet. The antenna weighs under 61 pounds. I know you're saying, why so heavy? That's a lot of material that it takes to support that much wire. We also have, with that antenna, the ability to add what's called a broadband adapter. And that broadband adapter is actually if you can imagine in your mind, a terminated loop that's in the shape of a pennant type antenna. So it acts like a steerable or rotatable dipole. So even though you've got a 40 meter antenna through 10 meter antenna, with the broadband adapter on it, you're now able to do 160 up to 80 without a problem whatsoever. And with your amplifier, that'll generally compensate for the losses that you would incur because the antenna itself isn't a full-size 80 meter or 160 meter antenna. And then the other thing you need to think about too is that the antenna itself, because it is generally higher than what you'd normally have your normal dipole antenna, an 80 meter antenna at 100 feet, what will that do? Think about it, folks. Yeah, you're probably not going to be able to talk to someone locally, but someone else on the other side of the continent is probably going to be able to talk to you, which is exactly what we've been dealing with. We've got one customer in Jamaica and another customer in Florida, and he was pretty upset with us when he first installed the broadband adapter on his 40 meter antenna that he had 110 feet in the air. He couldn't talk to anybody locally. He could only get places like, Finland, Germany, places in South America and so on. So the local people weren't really able to he wasn't able to communicate well with the local people within 200, 300 feet. But think about it. You're an 80 meter rotatable dipole at 110 feet in the air. What's going to happen? Yeah, that's what I thought. But the nice thing about that is it does give you that functionality. And then because it is a terminated loop, it's super quiet. So, you can pretty much figure out where the signal is going because you have a null on the side of the antenna. I'm going to see if I can pull this design up for you real quick so you can see kind of how it looks. 1 second while I pull this up here. One moment. This is where we should have introduction music or whatever. Okay, here you go. Okay, this is a little bit more of a technical diagram of the antenna itself. There we go. How's that? Okay, as you can see, you've got the hex beam itself, and this is the broadband element itself. And as you can see, it's basically in a pennant shape. And we can also do the broadband adapter on the 20 meter as well. The 20 meter and the 40 meter kind of look the same when we're doing the broadband type function. And as you can see, you've got each element. For instance, you've got your 6 meter element here. You've got a 10 meter element. You've got a 12, 15, 17, and 20. And then, of course, you have the broadband element, which is this thing in green. This kind of puts the antenna itself, the hex beam antenna itself, in a class of itself, because the hex beam, as it is a fantastic performer. Adding the broadband adapter to the antenna puts it in a class all of its own. It's kind of like a Swiss Army knife. It does a little bit of everything. Now on 80 and 40 on that hex beam diagram, it's not going to be like if you had a full-size dipole and you had it set up exactly right. But guess what? You're able to work it on that one antenna. And we have people who, this is what they would prefer. They want that ability to work with one antenna in one little space. And at 19 pounds, you can almost use, and some people do use, a TV rotor on this thing. Now, TV rotors don't have brakes, so you never know where your antenna is pointing if you use that. We do recommend something like the
Our next hourly prize drawing. Prizes this hour are courtesy of Batteries America.
Batteries America.
Adapter guy. Gigaparts. Tower Electronics.
Okay, I'll just keep going. I'll just talk closer to the microphone so that way everyone can hear me better, and we're not going to have to listen to the other people in the background. Anyway, the interesting thing about that, where was I, by the way, please? I got interrupted by the announcer. Okay, we were talking about 19 pounds, being able to take it anywhere. You've got the broadband capability of the antenna. You're looking at something that is kind of like a Swiss Army knife. I'm not going to say it's the best end-all, does everything in the world, but in many cases, this is what a lot of people want. For the longest time, all I ever really used were dipole antennas. As a matter of fact, that's what I do. I build wire antennas. Can you imagine that? I never even considered doing the hex beam antenna until I realized it's a resonant dipole antenna. When we deal with antennas that are, all these different kind of makes and models and designs, what do you think happens when you have to compromise? When you compromise, you lose something. Is a resonant antenna more functional than a non-resonant antenna that you just hooked with this thing called a tuner to it and made it work? I can pretty much tell you that resonant antenna is going to be the more functional antenna than the non-resonant one. Something that you don't have to do a lot to make work is going to be the thing that's going to work better for you. That's what you get with something like the hex beam. It's a resonant dipole antenna with a reflector in a smaller space. And so in my mind, that's kind of the cat's meow. And unfortunately, where I physically live, I live out in the woods kind of, but believe it or not, they have housing or covenants and stuff like that where I can't put up an antenna install and all that. So what I've done is I put up a DX160 one way, a DX80 and the other way up in the trees, and I've kind of snuck it, kind of under the radar. With this antenna, believe it or not, it doesn't look necessarily like something that most people would be expecting to see when it comes to an antenna. It doesn't look like a normal beam antenna. And when you start playing with it, because of its directivity, because you have the ability to pretty much point and shoot, guess what? I'm able to do things that I haven't really been able to do before. We've got, I don't know how many of these antennas being used as net control stations. We've got one station down in Jamaica that I talked about before. He's a net control station for, I can't remember, it's not the Hurricane Watch, but some other maritime operation where he wants to be able to listen to a general area, but he doesn't necessarily need to have the laser pointed capabilities of like a multi-element beam. So he wants to listen to something that, let's say, has a 45-degree span. He wants to point in that direction, be able to pick up anything there. That's what he's got. And everyone behind him, he generally can't hear, which is a nice thing to have. By having that selectivity, you're able to now do things with an antenna that's light, it's easy to use, takes about 30 minutes to install, I do have a video that I put together real quick that we can probably start playing in the background. Anyway, I've got a video that we can start playing in the background that kind of shows some of the main features of the hex beam, plus the it took me 30 minutes to put the antenna together, but you're going to see it in 3 minutes because I did a time lapse. Okay, and hopefully they'll be putting it on the main screen here in a few seconds. The nice feature of it is, like I said, it's easy to put together when you buy the product. When you get the product, everything's been pre-cut. Everything has been pretty much cut to length, put into its proper position. All you have to do is final assembly. How many tools do you think it takes to put together a hex beam when you get it? Someone take a guess. 6? 0? Well, I bet you could do it without any tools. 2, you're right. It takes a number 1 Phillips head screwdriver and a 7/16 wrench. That's it. Okay, that's not too bad. The couple things that I'll go ahead and point over what we've already talked about: 6 bands, full power, 1 feed point, 20 dB front to back. Okay, so that's considerable. You know, when you're looking at a difference between being able to hear something and not being able to hear something, it makes quite a difference. 30% smaller than a normal beam. That's a significant thing. I'm going to start singing here in a few minutes. Okay, here we go. Basically, you're going to see us putting together the hex beam in 30 minutes. By the way, my dog Zoe, she's here with me right now. Actually, she's right behind the red curtain. We're going to be able to put this together in about 30 minutes, and it'll take about 3 minutes on the time lapse. And no, I really don't move that fast. Well, I could move that fast if I had a chance. And as you can see, each of the components are pretty much set up. They're pre-spaced. All of the elements are pretty much put in the position that they need to be in order for you to put the antenna together. And what you're seeing here is you're basically putting, the individual elements in. First 2 elements, second element, doing the strings. Oh, this is one of our first ones. This is one that we sent to Alaska where the guy needed extra support. So we put a support mid-span to give him a little bit more strength, because in Alaska, what happens in Alaska? Has anyone ever watched Deadliest Catch? Okay, it's kind of like that. I mean, you're talking about a foot of ice and snow hanging off the antenna. What happens to your normal beam when you have a foot of ice and snow hanging off that aluminum beam? That's right. What happens when a beam bends that's made out of aluminum? That's right. It bends, it stays that way. With the hex beam, when it bends, it just bends and it pops back into shape. Imagine a reed of grass. When it blows in the wind, it flexes, it moves, it does all kinds of things. Oh, we're done already? Ah, there we go. Okay, does anyone have any questions? Oh, there we go. Okay, never mind. Okay, that's fine. Sounds good. Anyway, as you can see, we're moving things around. All the wires are pre-cut. Each of the individual elements have already been pre-cut to the proper length, and they're color-coded. So you don't have to worry about even looking for the numbers. You put the red with the red, the blue with the blue, the green with the green, and you're good to go. We did this for 2 reasons. One, I'm ex-military, and in many cases, I'd rather go with a color code than trying to figure out number nomenclature. And sometimes a 5 looks like a 6. Am I right? Sometimes a 0 or even a 1 can be an I. I don't know.
Good afternoon.
Good afternoon! Anyway, sorry about that. I had to do that. Please forgive me. Anyway. Anyway, I'll be right back in a second here.
And first of all, I would like to welcome you to the Huntsville Hamfest.
Yay!
The Young Ham of the Year Award has been
okay, 30. Okay.
At the Huntsville
all right.
For
how long?
20 years at least. I've been involved
2 minutes.
For 20 years, and it's always been here. So.
Okay. All right. Well, we got about 2 more minutes to go. And yes. When the antenna flexes under extreme conditions, does it change the pattern? It may change it a little bit, but not much. we've already had a couple situations where it's gone through 90-mile-an-hour plus winds, and it still worked. The issues is when it's iced over and stuff like that, generally you really wouldn't want to operate the antenna when it's in an iced over condition. Even as a chief engineer from working at radio stations, I would never, operate under those conditions and wait till things, basically thaw out. Or you could just kind of turn on the amplifier, the wires get warm, everything melts off, and then you can start operating again. Anyway, I've been told that I've got a couple more minutes to go, so hopefully I'll be able to fight myself over all the announcers and stuff like that. So, yes. Is there a minimum height? Interesting thing. So far in this country that I've been doing a lot of my shows at, I'm operating from about 10 feet off the ground. Minimum, I would say 15 to 20 feet is operation. I've got a couple ham radio operators that have only 15 feet on the back, off their back fence, and it works great. He's talking all the way around the country on 20 meters. 25 to 30 feet is optimum for this antenna. You can go up even higher. Anyway, sorry about that. Any other questions?
Her name is Anna. Anna Veal.
Are we done?
W0ANT. Let me just
Commercial? We're done?
Anna is the
okay.
daughter of Paul Veal.
Hello. And then we're going to commercial now. Okay, you have to forgive me. Normally I don't talk to the people in the background, but okay, we're going to be ending this segment now, and then we're going to go to commercial. This is Emmett Hohensee with Hamfest TV, sponsored by Gigaparts.